Install units are used in drop-in applications. The housing below the framed cooktop surface contains all the unit's components with the exception of the potentiometer, which is connected with a cable and RJ45 connections. Remove the screws securing the unit under the cooktop. Carefully lower it. The cooktop glass shouldn't have to be removed. The component box is suspended on studs at the front. Carefully slip it down and back to disengage the studs. The unit can be placed on a workbench for repairs. Here it is shown with the potentiometers attached. The sensors, multi-point rather than circular, are different from those on single-coil tabletop units. The front coil is controlled by the potentiometer on the left. The rear coil by the potentiometer on the right. The front coil is connected on the left. The sensor for the front coil is the single cable visible on the right. The sensor for the rear coil is the single cable visible in the center. All are labeled. Screws attach the coil assembly to the component box. Remove the screws and disconnect the coils and the sensors. Lift the assembly to see the components. The 208-240 unit is shown here. The current flows in and goes through the filter, the main component in the front of the box. There are 6 fuses, 2 for each leg of the 3 phases. Power then flows to the power board along the right side of the box. The rectifiers for both sides are visible under the sheet metal, as are the coil connections. The wire on the left side of the box puts 208 to 240 volts AC on the AC-DC power supply. It supplies power to the distribution board, which supplies 24 volts DC for the power board, the fan, and the controls. +5 and -5 volts also flow through the CAN board for the CPU and the potentiometers and the infrared transmitter. Here's an annotated view of the component box. And a look at the wiring diagram. The 400 volts AC box is shown here. The arrangement is similar, although it has 3 fuses rather than 6. Here we see the fuses on the main filter checked for continuity, a test used when the unit is non-responsive. There's a 1 amp fuse, which protects the power supply. Disconnect the wiring connecting the filter to the coil assembly. The fan has to be disconnected to remove the assembly from the component box. Here the components, minus the filter and the fan, are removed from the box. The connections for the power supply, the signal optimizer, and the communication bus are seen on the power board. To remove the power board, remove the coil connections to the signal optimizer. Mark the positive and negative leads. Remove the 3-phase that flows through the coil. Standoffs have to be removed. The tests for the board are similar to those performed on tabletop power boards. Here the rectifier is tested. Hold the negative probe to the positive connector on the rectifier. Hold the positive test lead on each of the 3 AC leads on the board's terminal block. In this case, the failure of the rectifier is predicted by the discoloration near the IGBT. The failure of the transistor usually occurs first and takes out the bridge rectifier. If the power board fails, it must be replaced. There are no serviceable parts on the board. The output from the power supply can be tested with the unit connected to power. The adjacent connectors serve the same purpose and are interchangeable. With the positive lead on pin 1 and the negative lead on the next pin, 24 to 28 volts DC is seen. With the negative lead on the same pin, move the positive lead to the third pin to check for +5 volts DC. Move the positive lead to the 5th pin to check for -5 volts DC. Failures of the power supply can be caused by problems within the power board, the CAN interface board, or the CPU. Misplaced plugs, pins missed, also cause problems. The CPU has a heartbeat LED. It's seen flashing here, which means it has communication. Voltage can also be checked on the cable that attaches the CAN interface board to the CPU. 24 volts DC, as well as signal voltage travels on the cable.